In today's lesson, we are going to work on equations that have parentheses or brackets in them. So remember, when we're solving an equation, the goal is to find the value of g that makes the statement true. So g is being added to 4 in the brackets first and then multiplied by 2. So we want to undo all the things happening to g in order to get g all by itself. It's called isolating the variable. So we have two options here. Number one is we do BEDMAS backwards. If g is being added to 4 in the brackets and then multiplied by 2, if we knew g, we would get -8. So what would we have to undo first? Well, we have to go backwards. We have to undo the last thing that happened to it. So we would have to, let's write this out. Go to blue. We get 2g plus 4 equals -8. We would have to undo the multiplying by 2 first. And the golden rule of algebra, whatever you do to one side, you do to the other. So that undoes, right? So when we undo multiplying, we divide and we use fraction bars for division. So I get g plus 4 equals, keep that equal sign lined up, -4. Now I want to undo that adding 4. So how do I undo adding 4? I subtract 4 to both sides. Or in other words, it's going to disappear on this side and appear on the other side as -4. So this 4 now becomes this -4, right? Okay? Or we could have shown our work this way. Subtract 4 on this side, subtract 4 on this side. All of this cancels out. So now we're left with g equals -8. Okay, so if I plug -8 back in, -8 plus 4 is -4, and then -4 times 2 is -8. Yes, that works. Now, there's one other way we can do it when we have parentheses, and we're going to call this method 2. Okay, the other way we can do it is before we start isolating the variable, we can eliminate the brackets. So we can simplify the left side of the expression. So we eliminate brackets with our distributive law. So if I multiply the 2 in, I do that first. Now I can begin solving my equation. So this time, if I know g, I would multiply by 2 first, then add 8 to get to -8. So since I'm adding 8 second, I now deal with that when I'm undoing it first. So if I want to move the 8 to the other side, it becomes -8. Or in other words, I'm subtracting 8 from both sides, and that cancels out. So my next step, I could just write 2g, the 8 goes to the other side, I get -8 minus 8. 2g equals -16. Now I'm going to divide by 2, and I'm going to get g equals -8. They both get you to the same answer. One of them undoes the multiplication first, then undoes the inside brackets. The other uses the distributive law to get rid of brackets and then solves using BEDMAS backwards. Let's try another one. Let's use both methods. In the first method, I would divide both sides by 3. I would get r minus 2 equals 1. I would move the -2 to the other side. I would get r equals 1 plus 2, and therefore r equals 3. That would be method 1. Or method 2 would be to remove the brackets first using your distributive law. Move the -6 to the other side. Collect like terms. Divide both sides by 3. And we can do it that way as well. All right, so both methods work. However, I would say method 1, I would only recommend method 1 if the number in front here divides into both of those numbers. Otherwise, you're left with fractions. So you got to think about that. If you're getting a fraction when you divide that number out, I would always use method 2. Okay, for example here. This number divides into -20. So since 5 divides into -20, method 1 works fine. We can use method 1. So we divide both sides by 5. We get -4 equals 3 plus p. We move this 3 to the other side. We get negative 4 minus 3 equals p. Or we get negative 7 is p. All right, so we can just do method 1 there and no fractions. Or another thing is, what if this number in front is a fraction? Okay, what's the opposite of multiplying by a quarter? Or in other words, how can we get rid of that 1/4? Well, the opposite of multiplying by a quarter is the same as dividing by 4. Multiplying by a quarter is the same as dividing by 4, right? So the opposite of dividing by 4 is multiplying by 4. So if I multiply by 4 on each side, in other words, the reciprocal of that, when I multiply by the reciprocal, I get 1. If I multiply both sides by 4, then I'm just left with 8x minus 20 on this side, and 4 times negative 2 is negative 8. So don't forget, if it's a fraction and you want to get rid of that fraction, if you multiply by the reciprocal on both sides, you can eliminate that fraction. Now I can continue, and I can say, oh, I'm going to move that negative 20 to the other side. It becomes positive 20. Collect like terms, divide both sides by 8, and oh, I get a fraction answer, which is fine because not all answers are integers. And so I'm going to get divide by 4, or in other words, it's the same as 1.5, right? So here's an example where method 1 isn't a great choice, because if I tried to divide both sides by 4, 15 divided by 4 does not go evenly. Then I would have to be adding and subtracting fractions in my algebra. I don't like to do that. So this is where I would say, okay, I'm now going to use method 2. I'm going to eliminate brackets first. So I get 4x minus 12 using my distributive law. Now I'm going to add 12 to both sides, or in other words, when the negative 12 moves to the other side, it becomes positive 12. I get 4x equals 27. I divide both sides by 4. Now my final answer is a fraction, even though I didn't have to work with fractions. So 4 goes into 27 7 times. No, it doesn't. It goes in 6 times with 3 left over. Okay, so 6 3/4. A little note. Before you isolate a variable, each side of the equation must be simplified. So I typically always use method 2. Unless it's a very simple one. If it's very simple and I can see that this number divides into this number nicely, I would use method 1. Otherwise, I'd say majority of the time I use method 2. I get rid of brackets before I solve. Okay? If you have multiple sets of brackets, for example, this one, you have 2 sets of brackets on one side, then guaranteed use method 2. Get rid of all your brackets and collect like terms before you solve. Because an equation is basically the equality of 2 expressions. This expression equals this expression. So we had a chapter on algebraic expressions, and we learned how to get rid of brackets and collect like terms. Or in other words, I call that expand and simplify. The expand part gets rid of the brackets, and the simplify part collects like terms. So before you solve, simplify each side of the equation. The right side can't be simplified because it's just a number. So let's simplify this. We're going to multiply in the 5 and we're going to multiply in the positive 2. Don't forget that sign goes with the 2. So I'm going to get 5x minus 5 plus 4x minus 2 equals, and that stays 11. Now I'm going to collect like terms. Always collect the x's first, then collect the constants second. Now I have an equation that is 2-step. X is being multiplied by 9 and then subtracted by 7. So I'm going to undo those. I'm going to undo the subtract 7 first by adding 7 to both sides. So that becomes add 7 when it moves across. Collect like terms. Now I'm going to divide by 9, and I'm going to get x's 2. All right, so make sure you've simplified, you've expanded and simplified each side of the equation before you solve. Let's try one more. Okay, this one's tricky. I'm going to expand first so that 3 goes in. This plus 2 is not being multiplied by anything, so I just write it down. Plus 2x just comes down. It follows along in the same order. This minus, when there's nothing beside the bracket, we put a 1 in there, right? There's really a minus 1 in there. So I'm going to multiply in my negative 1. Take that negative with it. Negative 1 times 5 is negative 5. Negative 1 times negative x is positive x. And that can't be simplified, so I just write it down. Now we collect like terms. All of our x's first. Always collect x's before constants. 3x plus 2x is 5x. 5x plus 1x is 6x. Now I'm going to collect my constants. Negative 6 and negative 5. I've now simplified it down to a two-step equation. Now you can go ahead and solve. This part becomes quite simple because it's the same steps. You just have to be good at adding and subtracting integers. So the 6x stays, the negative 11 becomes positive 11 on the other side. So I get 6x equals 4. Divide both sides by 6. Always make sure it's the number in front of x you're dividing by. It's not necessarily going to be a number that is not always going to be the bigger number divided by the smaller number. This answer is going to be fraction. It's going to be less than 1. I'm going to reduce it to lowest terms. My answer is 2/3. All right, so that is multi-step equations using parentheses or brackets. How can I create an equation with parentheses? Here is making a square quilt with a 4-centimeter border around it. So the width is 4. So that width is 4, that width is 4. It doesn't matter where I draw the width, it's 4 centimeters, okay, around it. And she wants the perimeter to have, or the perimeter, so this plus this plus this plus this to be 600. Okay, the full lengths to be 600. I could divide that by 4 and figure out one length, but let's just make the whole thing. We know 4 multiplied by something equals 600, right? We could divide by 600 to find one of them, but let's just keep it like this, where 4 groups of something equals 600. Well, 4 groups of this is 600, right? So we need to know, what is this total length? Well, this length in here, we can call x or s, whatever we want. We'll call that x, right? So those are all x inside. We know the border is 4 centimeters, so we know this distance is 4, and we know this distance is 4. So what's this total distance? Well, it's whatever x is plus 2 4s, or in other words, plus 8. So x plus 8 is that total distance. And so this distance is x plus 8, and this distance is x plus 8, and this distance is x plus 8. In other words, I have 4 groups of x plus 8. Can we now find the x? Yeah, we can solve this equation. We can divide both sides by 4, right? And then subtract 8 from both sides. Or we can use our distributive law and solve the equation. But I just wanted you to write an equation, so this would be the equation representing the outer perimeter 600 with a border of 4.